Next one, we're going to be talking about the equivalent fraction. We're going to be talking about the word equivalent fraction. This is one type of fraction, okay? It's one of the types of fraction we have. Now, the equivalent fractions are fractions that look different but mean the same fraction. They look different, yet they mean the same fraction. That is what we mean by equivalent fraction. That is what we mean by what? Equivalent fraction. Sometimes fractions look different, but they represent the same object. They do what? They represent the same object. Okay, when you have a fraction, numerator on top and the denominator at the bottom, you can multiply the fraction with any number of your choice, as long as when you multiply with any number, it must be the same with the denominator. That is how we make the equivalent fraction work. Okay, when we want to make a fraction equivalent, we have to make sure that the number we use in multiplying the upper part, we also use it in multiplying the lower part. We talked about the numerator being the upper part and the denominator being the lower part. So the number you use in multiplying the numerator is that same number you also use in multiplying the denominator. You will not use a different number if you want to have an equivalent fraction, an equal fraction. Like example 1, 1/2, 1/2 and 2/4. As you can see, the numbers are different, right? The numbers are different, right? Yes, they are different. And I'm going to explain how they are different and how the objects still look the same, right? Okay, 1/2. One part of the object is shaded, right? The circle, one part is shaded, right? So it's called 1/2 because the shaded part represents 1 and the full circle is represented by 2, which is the number, sorry, 1 is the numerator and 2 is the denominator, right? 1 is the shaded part and 2 is the whole object, which is divided into 2, right? So one part is shaded, right? Good. Now we will multiply our numerator by 2 and we will also multiply our denominator by 2. When we do that, 1 times 2 will give us 2, right? And 2 times 2 will give us what? 4. That is how we got this 2/4. Now 2/4, we can see the circle beside it, right? The circle is divided into 4 parts, right? That's why the denominator is 4. And how many parts are shaded? 2 parts. How many parts are shaded? 2 parts. That's why it's called the 2 is known as the numerator, because it does what? It represents the shaded part. Okay, now how do they look the same? Who can tell me? The both circles are into half. The both circles are was into half. If you look at the first object and the second one, they look the same, right? The numbers are just different. The numbers are just what? Different. The both circles are into half, but the numbers are different. The first one is 1/2 and the second one is 2/2, but the both objects are in equal parts, right? The both objects are in equal parts. That is what we mean by equivalent fraction. The numbers may look different, but the objects will look the same. The objects will look what? The same. So how do we get this? We will make sure that whatever number we are using to multiply the numerator, we are also using that same number to multiply the denominator. Just as I used 2 to multiply the numerator and used 2 to multiply the denominator, it gave us a different number, but yet they both represent the same thing. They both represent the same objects. Okay, our number 2 is 1/2 and 3/6. 1/2 and 3/6. They are different numbers, right? The first one has 1 as its numerator, and the second one has 3 as its numerator, right? The first one also have 2 as its denominator, and the second one has 6 as its denominator, right? So they are different numbers, but if we look at the object, they look the same, right? They look the same, right? Now, what did I do? I used the same number in multiplying the numerator to multiply the denominator. I did what? I used the same number to multiply the numerator to multiply the denominator. So 1 over 2, the shaded part is 1, and the whole object is divided into 2. That is how we go 1 over 2. And we use 3 2 times, right? We use 3 2 times to get 3 over 6. We said 1 times 3 giving us 3, and 2 times 3 giving us 6. Now, if we look at the object beside 3 over 6, we see that the object is divided into 6, right? It's divided into 6, right? And how many parts are shaded? 3 parts. But if we look at both objects, 1 over 2 and 3 over 6, we will see that they both look alike, right? They are both divided into half. They are both what? Divided into half. Very good. I hope we understood, right? Good. Now let's go over to more examples. More examples. Number 1 says 7 over 10. 7 over 10. 7 over 10. Now let's get a look at a different number from 7 over 10, but it also represents the same thing. It also does what? Represent the same thing. Like, if you remember what we said, most fractions will look different, but they represent the same thing. 7 over 10, we have A, we have 1 over 4. B, we have 14 over 20. C, we have 3 over 21. D, we have 21 over 30. And E, we have 14 over 10. I hope we are with our pencils and book ready, or pens and book ready to do this example with me. Okay, very good. We will say 7 over 10 is equal to, let's think, what are we going to use to multiply to give us a good fraction that will look different from this 7 over 10, but it will remain the same in object form. We will say, okay, if we use 1 to multiply, our answer is not in A, B, or C, right? Try using 1. 7 times 1 is 1, and 7 times 10 is 70. Do we have that answer there? No. So we are going to use 2 next. 2, so let's try it. 7 times 2 there, it gives us 14, and 10 times 2 it gives us 20. Am I right? Is our answer there? Let's check. A is 1 over 4, B is 14 over 20. Wow, that is our answer, right? So we'll pick 14 over 20. Then let's think again. Which other number can we use to multiply the numerator and the denominator? Okay, let's go with 3. 7 times 3. 7 times 3 will give us what? 21. And 10 times 3 will give us what? 30. So we have another fraction that is 21 over 30. 21 over 30. Let's check if our answer is there. A, 1 over 4. No. B, 14 over 20. We have gotten the answer before. C, 3 over 21. No, our answer was 21 over 30, right? So C is not our answer. Then D, 21 over 30. Wow, that is our answer, right? Very good. So now we think again, which other number can we use to multiply? Which other number can we use to multiply? If we use 4 to multiply, I feel like it will give us a bigger number, but let's try. 7 times 4 will give us 28. There are no 28 in our options of answer, right? No. So we will not bother using that. We have gotten 2 answers, and our answer is B and D. So you use your pencil or your pen to circle your answer. Number 2. Number 2 is 3 over 8 is what? 3 over 8. We are going to look for numbers to multiply both the numerator and the denominator that will give us a different fraction but will also mean the same thing. That will do what? Give us a different fraction but will also mean the same thing. Okay, let's go. 3 over 8. 3 over 8. What are we going to use to multiply first? Let's go with 2. We'll do 3 times 2 over 8 times 2. What are we going to get? 3 times 2 will give us what? 6. And 8 times 2 will give us what? 16. Let's see if our answer is in the option A, B, C, D, or E. A says 1 over 8. No, our answer is not there. B is 3 over 16. No, that is not our answer. C is 6 over 16. That is our answer. So we'll circle 6 over 16 as our answer, right? Very good. Now we're going to think of another number that we can multiply and also get a different fraction but will give us the same meaning. Now let's think. Let's go with 3 to see if our answer will be there. We start with 3 times 3 over 8 times 3. What is it going to give us? 3 times 3 will give us what? 9. Very good. And 8 times 3 will give us what? 24. Good. So let's check if our answer is at the answer 1. Sorry, A 1 over 8. No. B 3 over 16. No. C 6 over 16. That was our first answer, right? Now D 9 over 16. Is that our answer? No. Let's check E. E is 9 over 24. That is the answer we got, right? Yes. So we have gotten an answer that as different fraction but will give us the same object. It will do what? Give us the same object. Very good. Okay. Okay, so how do we know if these our answers we have solved is correct? The first one, 7 over 10. Okay, you draw a circle, divide the circle into 10 parts. You do what? Divide the circle into 10 parts. Then shade 7 parts. Remember, the 7 is the numerator, so we are shading 7 parts and we are dividing our circle into 10. So when you do that, shade 7 parts. The next one you will do is to draw a circle again and divide it into 30 parts. You do what? Divide it into 30 parts and shade 21 parts. If they look alike, that means our answer is correct. And I'm sure it looks alike, right? Yes, very good. I hope you tried this exercise, okay? Then 2. 3 over 8. How will we know if our answer is correct? We'll draw a circle and divide it into 8 parts. The 8 parts we are dividing it to is called the denominator, right? Because the denominator represents the whole object and we have to divide it into 8 parts. And how many parts are we going to shade? 3. How many parts are we going to shade? 3, because 3 represents the shaded part and is called the word numerator. It is called the word numerator. When you have done that, you do the next one. You divide the circle into you divide the circle into 16 parts and shade 6 parts and do what? Shade 6 parts and do what? Shade 6 parts. If they look alike, that means it's correct, right? You do the same for the next one. You draw a circle and divide it into 24 parts and shade 9 parts. I hope you try this exercise. Okay, there are more exercises for us to try. You do the remaining 3, 4, 5. Okay, and get your answer and make sure it's correct. You practice it, you draw your circle and when you get your answer, you do the rest. Okay. Practice make perfect. Practice does what? Make perfect. So we should practice at home and know more on how to get an equivalent fraction. Okay, very good. when we do this exercise, we should make sure that they are correct. Tell our mommy, daddy, sisters, brother, uncle to check it for us. Okay, bye.